So
Okay.
we're good to go.
Thank you. Thank you very much. Good morning, good afternoon. My name is Piotr Kałuża, and I'm a solution architect in Sycope. And I'm happy to be here to show you our solution and show you how we can help to achieve what you want, what you need to achieve. So do not waste the time. I've got a short demo presentation. I've got also the PPT presentation to give you the basic information about the company, about the technology, and exactly how we can help you. So, okay, let's start. The first information about the company: who we are. We are a company established in 2019. In this time, we released the first version of our product. However, we've got experience from the another projects. We came to the company from many different places, from many different sectors of the market. So our experience is much bigger than this last 3 years. We completed around 400 projects, and right now we've got 15 active clients in our pocket. So okay, the information why you should choose Sycope. The first thing is that we are really customer oriented. So we are waiting for the feedback from the customer. We are listening our customers to know what they need and how we can help them to improve the network visibility and security. As a new company, we do not have the roadmap for next 3-5 years. We are very flexible in this case. When we see that something is important for our customers, we can add it very quickly. The another thing is experience. As I said, we come from different part of the market. We've got different experience, and we connected our experience to give the real value to the market. And our product is very flexible. As I show you during the presentation, we've got many predefined views, rules, but also you can create your own based on our views or rules, or you can create your own views or rules just from the scratch. So it's very flexible approach. You can do exactly what we did preparing the views in the product. So it's flexible, it's fully customized. Where we are. Our main office is in Poland, in Warsaw. However, we've got also offices in Czech Republic and in Germany. For now, we are visible especially in the CE market, but we are talking with another partners, with another distributors in the Western Europe. So I think that at the end of this year, we will be able to cover whole European market. Who trusted us? As you can see, we've got few huge customers. This is not the list of all of our customers, because some customers do not want to share the information that they are using some specific product in their environment. So here you've got only these customers who decided to share this information with the rest of the world. So as you can see, we've got customers who are banks, to our ISPs, and many different other customers. Where you can buy Sycope, of course, in this case, you can buy Sycope from Softprom. At the end, we can discuss about our portfolio, about our modules, and about the level of the licenses. So we can leave it at the end of the presentation. And I would like to announce that we've got room to talk just one-to-one, and during or after this presentation, we can talk there, and I will be happy to answer your questions. Okay, so this was about the company. Let's talk more about the technology. Okay, so as you can expect, we are focusing on the network monitoring, but in this moment, I would like to tell you that we've got two different solutions when we are thinking about the network monitoring. The first one is network device monitoring. So in this part of network monitoring, we usually use SNMP protocol to get the information about the network devices. So in this part, we can get the information about the CPU saturation, about the network interfaces saturation. It can give us a lot of information about the situation of the network devices, but this approach do not tell us anything about the why this situation occur. So we see the huge saturation of the network interface, but we don't know who did this traffic, who is responsible for this saturation. So this is the network device monitoring. We are working with network traffic monitoring. So we can tell you who is responsible for this situation. We can tell you who is the client, who is the server. We can tell you what application is used the most in the network, internal network or single segment of the network. So we can tell you all this information. We can also present you the information about the relations between the computers. So we can tell you, okay, this is the client IP, this is the server IP, and they used, and we can show you the list of the applications, of the protocols used to the communication. So network traffic monitoring is to show the information who, with whom, exchange the data, how many data, for how long they exchange the data in the network, and it can give you the real information about the network situation. So what is the architecture of the solution? We are using a single VM called Sycope collector to collect the data from different network devices. We can use data from firewalls, routers, switches, etc., because all those devices can send us the flow data. Flow data, I mean NetFlow v5, v9, IPFix, SFlow, NCell, or something like this. All vendors can create some type of flow data, and they can send this data to us, and we can collect it, analyze it, and visualize it at the end. In some cases, it's not possible to create the valuable data from the network device. Why? Because some devices are not developed to create the NetFlow data. So in this case, we can help you adding Sycope probe to your environment to create the better flow data. How we can do it? On the NetFlow device, network device, you have to configure something what is called span or mirror port to send the copy of the whole packets of the communication to our probe. Our probe will transform this data, these raw packets, into the NetFlow data and enhance this information for very specific additional information. So thanks to this, that we can see all packets, we can measure delays, we can measure retransmissions, and put this information to the NetFlow data. Also, we can analyze layer 7 of the communication. Because we see the payload of the packets, we can put this information to the NetFlow data. So we can tell you that, okay, this is the HTTPS protocol, this is the HTTPS application, but in truth, this is the O365 communication, or this is the Facebook communication, or this is the YouTube communication. So we can give you the real valuable information about the application used by this computer, and we can analyze this information. Of course, we can also put additional information to this NetFlow data. So we can put the information about the DNS protocol or HTTP protocol. So we can enhance the NetFlow data using our probe. What is NetFlow? Probably you know, this is the protocol developed by Cisco in 1990s. Right now, all devices can create some kind of NetFlow data. We usually think about the NetFlow v9 or IPFix because, for example, NetFlow v5, it's not really valuable because it's old. So it cannot analyze IPv6, for example. So the newer version is better version for us. So we can analyze NetFlow v5, but we recommend to use NetFlow v9 or IPFix. We do not talk anything more about the NetFlow. It's not the part of this presentation. Okay, when we receive the NetFlow data, we can collect it, of course, and we can analyze this data in our solution. So we've got 3 models to analyze the data. The first, the obligatory model is visibility. You cannot buy collector without visibility model. So this is the main model of our product. In this model, you can see the statistics of the traffic. You can see the details of the traffic. You can analyze the traffic saved by collector. During the presentation, I will show you this on the real environment, on the real device. The next model is performance model. This model needs the probe, because probe can measure the delays, can measure the retransmissions, and the performance model can show you this information on the dashboards or in the report. So in the performance model, we can analyze the delays, we can analyze the retransmissions, and tell you that, okay, probably this is the place which is responsible for the slow network response. The last model is security. In the security model, we analyze the net flow data to find some patterns and to recognize the unwanted behavior in the network. So we can analyze whole net flow data, and we can say that, okay, in this net flow data, we can recognize the pattern of the scan attack, dictionary attack, or we can find the communication with some suspicious IP address. Security module is very, very important for the SOC teams, for security persons. So we recommend to use this module together with the visibility and performance, because right now it's hard to say that we don't need the information about the security situation in the network. So we recommend to use the security module with visibility and performance. However, you can recognize it as a security, as a separate module. Okay, so for now, I prepared the use cases to show you how we can use our product to help you achieve what you need. So at the beginning, visibility and performance. Okay. The first thing is compliance. I think, or I'm almost sure that you have to meet some requirements regarding the logs. So for sure, you should keep the logs for some time. It can be because of the national law, or it can be by your security police. So you should keep the information about the whole connections in your network for 3, 6 months, or even for a year. So how we can help you to achieve this? This is the compare between the net flow and the full packet capture, because we are talking about this. Usually, we are talking about these two types of monitoring to achieve the compliance. So net flow can reduce the data to the metadata in the proportion 500 to 1. So it means that we do not have to keep the whole communication, but we need to keep the information about who with whom communicated with, how many data they exchanged, in what time, and maybe some additional information which we called metadata. So if you would like to collect the full traffic for 10 gigabits communication, you should prepare yourself to save 75 gigabytes of the data every minute, 3.5 terabyte of the data each hour, and more than 100 terabytes of the data every day. So imagine that you have to keep this data for 6 months. Yeah, it's a lot. Of course, this approach has some pros. I mean, we've got full communication for forensic analysis or for diagnostic. However, there are too many details. This is too many data to analyze, and we need to put additional recorders to our environment. So the architecture of our environment could be really, really difficult in this case. And the last, and maybe the most important thing, that this is useless for encrypted communication. Right now, around 90% of the communication is encrypted. So we are using HTTPS and SSH, or many different encrypted protocols. So we save the payload, but it's useless for us because we cannot decrypt it. To achieve this same, I mean, to monitor 10 gigabit traffic using NetFlow required 150 megabytes per 1 minute. And it means that we have to save around 200 gigabytes per day. So you can compare those two values, and you can see that thanks to the NetFlow, you can keep the data for a very, very long time. Using the NetFlow, we can still see the full information about the network communication. So we see the sources, we see the destinations of the communication. This protocol, as I said, is compatible with many different devices and many different vendors. And we can use this information also for visibility and for security reasons. So in my opinion, of course, we can use somehow the packet capture, but I would say that it's not the full packet capture, but we can save the data for some specific time, for some specific communication, but not everything. We can or we should use NetFlow data to meet the requirements of the law. In our product, we added 3 other features to reduce the amount of data. So the first one is what we call stitch flows. When the network device sees the communication, it creates 2 flows. So the first one from the client to the server, and the second one from the server to the client. In our solution, we connect those 2 flows into the single connection log. So thanks to this, we can save the disk space, because some information in the real raw flow data is presented twice, because we still see the header information from the header of the packets twice in both flows. The second thing is data deduplication. When the communication goes through many network devices, all those devices will send us the flow data. So we should keep this information many times. In our solution, we decided to deduplicate the data. So we can add to the stitch flow the information that we saw this communication on this and that device. We can put additional information about the communication. So we can tell that, okay, we saw the communication on this device and on this and that interface of this device. We saw this information in this VLAN on this device and on that VLAN on another device. So we can add more information to the stitch flow than to reduce the information saved by us. And the third thing is the licensing model. We decided that we don't want to enforce our license to the size of to the disk size. So if you decide to buy our license, you can attach additional data store to the system and keep the data for a longer period of time. So if you need, you can extend the disk drive attached to the VM, and you can save the data not for 3 months, but for 6 months, or even if you put the new office to your environment and you receive the information from the new office, you need to add additional resources, but it's not depends on the licensing model. Okay, this was the case for the visibility model. Now we've got the case for performance model. So I'm almost sure, or I can say that I'm sure that you have some problems with the performance from time to time. So users are waiting for the application, and after some time they decide to ping you that, okay, something is going wrong. The application works very, very slow. Could you please help me? What is the typical answer in this case? It works. It's not in my hand. I see that the application server works. So maybe go to the network admin and ask him why the network works so slow. So what is the answer of the network admin? Network works perfectly. I do not see any problems with the network performance. Go to the guys from the applications. So what is the outcome of this situation? The user is angry because he or she cannot work and he or she doesn't know how to find where is the real problem. So we can help you in this case measuring the values like server network time, client network time, and the application initial response time. So in this case, we can measure the delays between the packets in the communication, and we can tell you that, okay, this is the problem with the application because the initial communication between the client and the server looks good, but the response, the first response of the application looks terrible. We are waiting for a very long time for the response. Or maybe this is not a problem with the performance itself. Maybe this is a problem with some retransmissions. So we can measure how many bytes and packets were retransmitted in the network. And thanks to this, we can solve some problems. In the specific situation, I saw that around 20% of the packages in the network were retransmitted because of some broken cable or broken network interface in the device. So definitely this is necessary to measure all those information in the system to get to know where is the issue. Okay, this is the place where I can show you the demo. Okay, so as you can see, we are in the real system. At the beginning, I would say that on the left side, you've got the typical menu with some typical information about the favorite dashboards. You can create the alerts, or you can configure the device. At the beginning, you can see your home dashboard. So you can analyze the information from this point. You can add something to the filter to analyze the data only for a single IP address or for a single application or for single network interface, you can do it just clicking on the value. Yeah, and after that you have to wait a second to see the result of it, or you can type this information to the filter. So let me show you how to find the information about the performance issues. So let's go to one of my favorite dashboard. This dashboard is about IP address performance. To analyze the performance, I have to analyze the data from my probe device. So I know that the exporter IP address of this probe is this public IP address. And I would like to analyze the data for last, let's say, 30 minutes. Okay, I've got it. And here I can see the information about the client network time. I see the information about the server network time, and I can see the information about the initial server response time. I can analyze this information for a single IP address. So I can put this address to the filter once again, clicking on it. And after few seconds, I can see the statistics only for this single IP address. Of course, I can analyze this data from this point, I mean, using the widgets and dashboards, but also I can go to the table and find the communications, the connections for which the number of retransmission was the highest, or the client network time was the highest. So I can find the single log line to analyze this situation. I can do it this way. I can also analyze the full information for this communication using the raw data. I can analyze this communication. I can find the details about this communication. So as you can see, the metadata in the NetFlow means that we can save a lot of important information about this this communication, not only informations from the header of the packets, but also informations from the layer 7 or additional information connected with the performance. From this point, you can also analyze the statistics. So you can click on the statistics button and you can analyze the information, the statistics for this communications. Of course, right now I'm using some filters, so I do not see the whole data. I can analyze only the data which meets the filter in my search bar. Working with the products looks exactly this way. Okay, this is the end of this first presentation. Right now, let's go to the security module and try to answer the question: do we need the security module in our network environment? You probably know the multi-layer security model. I think that all of you use perimeter security. I mean, firewalls or UTMs or next-gen firewalls or something like this. I'm almost sure that all of you are using endpoint securities. I mean, antivirus product or some security applications installed on the workstations. But I'm not sure that you are using network security. So for now, you've got informations from the firewalls, you've got the information from the endpoints, but you don't know what is going on in the internal network. So not all the traffic is visible by the firewall. You cannot install the antivirus software or on each device in your network, because it's not possible to install the antivirus software on the printer device or on the IP phone. So you cannot do it. So you are losing this layer of the security. Using the network security, you see whole communication between the hosts in your network. So you can see the information for device like printer devices, like IP phones, or for OT devices. So I would say that Sycope can be another brick in your firewall in your network. So this is a typical network. I know that something like typical network does not exist, but I need to create something like this to explain how we can help you to detect the unwanted traffic in the network. So we've got typical network with some firewall, with the router, with the switches, and with many different segments, and of course with many different devices in a single segment. So how to analyze the data in the single network segment, because the communication between the host and the printer device is not visible by the firewall, because it's in the same network, and the printer device does not have the antivirus software. So how we can analyze this communication, how we can detect the unwanted traffic? Of course, getting the information from the network switch and analyze it in our model. So what we can detect using this information? Of course, the attacks known as a network reconnaissance. So it could be port scan, vulnerability scan. It can be another phase of the attack. So it can be a password cracking or data collecting and data exfiltration. Yeah, in this case, we can help you to fill the gap in your network security. So what are the phases of the network attack? We are using Mitre framework to map the attacks on the phases of the attack. So I prepared the presentation to show you how we do it in a typical way. So the first phase of the attack is the initial access. In this moment, the victim usually receives some email or something, or some message on the messenger or something like this, to click on the link or to download the attachment and to run some suspicious script. In this phase, we cannot analyze the payload, so we cannot analyze the attachment. We cannot analyze the payload of the web page. However, we can see the communication with the suspicious IP address, and we can raise the alert in this phase. We are not the best solution in this phase, but we can raise the alert when we see some suspicious communication with the suspicious IP address. When workstation is infected, the next phase of the attack is discovery. So this computer is looking for another computers in the network to find another aim of the attack. This phase is in the internal network. So this phase is invisible for the firewall because everything is going on in the single segment of the network. We can detect many different types of the attack in this phase. It can be a scan, I mean horizontal scan or vertical scan. We can find the information about the suspicious activity in the network. We can detect the abnormal number of connections in the network to say, hey, something going wrong in this network segment. The another phase is the credential access. So we see that on the server, the SSH server works, and we would like to log in to the server. So we are using the brute force attack or dictionary attack or some spraying password to crack the password on the server to log on to the server. Once again, we can analyze the network traffic generated by this attack and say, hey, something going wrong. Probably the attacker is in the credential access phase of the attack. This is the source, this is the destination of the communication. Please look at this. Next, we've got the lateral movement. So the attacker tries to infect another computer using the current credentials, the credentials from the first workstation or from the server to infect another device in the network. Then we are going to collect the information. We are downloading the files from the file server to analyze it and to send this data outside the network. So in the exfiltration phase, we've got the data leakage. This phase is usually the last phase or almost the last phase of the attack. And this is another phase when the firewall can detect unwanted traffic. So the communication between the initial access and exfiltration is invisible for the firewall, but it's visible for us because we can analyze the communication inside the network. So some time ago I prepared the attack on my network. So I would like to show you how I can analyze this attack. This is the short video because it's not so easy to show it during the presentation. So this is the video of the attack, and during the video I will comment it how I did it. Okay, at the beginning we are on the main screen of the system. I can jump to my favorites dashboard. I can select the SOC dashboard to analyze the security situation in my network. I can see how many alerts were generated in the network, how many of them were visible in which part, in which phase of the attack. I can analyze it. I can see who was the top client, who was the top server of these attacks. As you can see, I've got many different views, but I would like to analyze the initial access. So I would like to see only the alerts in the initial access phase. okay, I can analyze who was the source, who was the destination, but the best place to analyze this information is in the alert table. So I can see all alerts generated by this detection rule. I can see who was the source. I can put this source IP address to the filter to analyze only limited number of alerts. Yeah, here I've got alerts only for this client IP address. Okay, I decided to remove the initial access to see other alerts detected for this IP address. So I realized that this host generated also the horizontal scan. I see the brute force attack on port SSH. So I can expect that the attacker tries to crack the password to the SSH server. Then I see the alert called high data transfer. So I can expect that the previous phase of the attack was successful, and now I've got the access to the data, and I can download the data from the server to analyze this information. And after that, I can jump to the raw data to analyze the flows, which can show me the information about the communication. I can analyze this information. I can see how many data they exchanged in that time. So this is how I can do it. Once again, I decided to remove the server IP address to see maybe another phase of the attack. Yeah, and I saw that I detected the communication with some external IP address. The alert is called high data transfer, but from internal to external. So I can expect that this is the communication, with the host in the internet. I can see how many data they exchange on which protocol. As you can see, it's 443, so it is HTTPS. So this data is encrypted, so I cannot analyze it without decryption. So in this case, the full packet capture is useless because I've got a lot of data, but this data is encrypted and it's useless for me. At the end, I realized that the client IP address right now is used by a crypto mining network. I can see that this host communicate with some crypto mining network. I can analyze this data. Maybe I should block this communication on the firewall to avoid the another communication with this IP address. Okay, let's jump to another slide. Okay. This is the summary of my presentation. I see that I'm exactly on the time. So the short summary, what you can get when you decide to use Sycope in your network. All data in a single place. So all the information about the network communication are visible on a single console. We can give you a pre-sales and post-sales support, so we can support you during the whole product life cycle in your network. value from day one. I mean, the configuration is really simple. During the POC, we usually need around 1.5 to 2 hours to run the collector, to get the information from the network devices and to start analyzing the data. And what I said at the beginning of the presentation, I will say also at the end of the presentation, that the easy customization. So you can filter the data as you want. You can create the views as you want. You can create the detection rules as you want. Of course, you can use our own, but you can also create your detection rules. Thank you very much for your time. You can ping me via email to ask for something. Of course, I'm also available for you to answer your questions. Thank you very much for your time. Have a nice rest of the day. Have a nice rest of the week. And I hope to see you soon.
Thank you very much, Piotr. We indeed have one question, which
Two questions.
Two questions.
Yeah.
So the first question is if Sycope has any kind of killer feature that separates you or that distinguishes you from other competitors. And the second one is why is Sycope better than Zabbix?
Okay, so maybe at the beginning I will answer for the second question because it's really easy. Zabbix is solution. I would say that we are not competitors at all because Zabbix focusing on the network device monitoring part of the network monitoring, while we are focusing on the network traffic monitoring. So we are not the competitors. I would say that both solutions are compliant. So this is the answer. It's hard to say that one solution is better than another one because both of them are for something else. Regarding the second or the first question about the killer feature, most of the solutions on the market which are analyzing the net flow are very similar. I would say that for some of them the real difference is between the white and black interface. So they are very similar. I would say that for us the real killer features are, because it's not the single feature, we've got 2 or 3 really key features on the market. The first one is the stitch flow and the deduplication. So we can save a lot of information on this same disk size. Comparing our solution to another one which do not use the deduplication and do not use the stitch flow, means that we can save around 50% of the data storage. The another one is the performance of our system. As you saw during the presentation, I was able to analyze the data without any delays. I just clicking, and after 1, 2, 3 seconds, I saw the information on the dashboard. So this is a very fast interface and data analysis. And the third one, this is especially for the security module, this is the licensing approach, because we are using the same performance for visibility, performance, and the security module. So the licensing is very easy, and we can analyze the security alerts with the full performance. I mean 30, 60, 120, and 250,000 flows per second. We can analyze it in the full performance in the network. Of course, if you would like to analyze more data, you have to attach more resources to the VM. But we are doing everything with the full performance, while the other products on the market cannot do it this way, because usually the performance of the visibility module is 2 or 3 times higher than the performance of the security module. For us, everything is on this same level.
Okay, thanks a lot for this